In this video for Positive Maths, we're going to look at complex numbers and division. So to divide a complex number by a real number, we divide each part of the complex number with the real number. So for example, if we have a plus bi divided by c, that's the real part divided by c plus the imaginary bi divided by c. So let's look at some examples. Here we have 8 minus 3i divided by 4. So that's 8 divided by 4 minus 3i divided by 4, which is going to simplify to give us 2 minus 3 over 4i. The second example, we have minus 2 plus 6i divided by 2. So that's going to be equal to minus 2 divided by 2 plus 6i divided by 2, which will give us minus 1 plus 3i. So again, this is similar to the rules that we find with algebra. To divide a complex number by another complex number, we multiply the numerator and the denominator by the conjugate of the denominator. Okay, so that's very important. So if we have a plus bi divided by c plus di, that's going to be equal to a plus bi over c plus di multiplied by the conjugate of the denominator. So that's multiplied by c minus di over c minus di. So we multiply above and below by the conjugate of the denominator. So let's look at an example. We want to express 6 plus 5i over 2 minus 3i in the form a plus bi. So we have 6 plus 5i over 2 minus 3i. So we're going to multiply by the conjugate of the number on the bottom. So that's 2 plus 3i. And then we take it a line at a time. So we're going to have 6 plus 5i multiplied by 2 plus 3i on the top. And 2 minus 3i multiplied by 2 plus 3i on the bottom. So if we multiply the brackets, we're going to get 6 by 2 will give us 12. 6 by 3i is going to give us 18i. 5i by 2 gives us 10i. 5i by 3i is going to give us plus 15i squared. On the bottom, we're going to get 2 by 2 gives us 4. 2 by 3i gives us 6i. Minus 3i by 2 gives us minus 6i. And minus 3i by plus 3i is going to give us minus 9i squared. The next thing that we're going to do is simplify and change. Everywhere we have I squared is going to change to minus 1. So we have 12 plus 28i plus 15 multiplied by minus 1 on the top. And we have 4 plus 6i minus 6i is going to give us 0. So we have minus 9 multiplied by minus 1 on the bottom. So we get 12 plus 28i minus 15. And we have 4 plus 9. So 12 minus 15 is going to give us minus 3 plus 28i. And 4 plus 9 is going to give us 13. So if we are writing it in the form of a plus bi, then we're going to have minus 3 over 13 plus 28 over 13i, where a is equal to minus 3 over 13 and b is equal to 28 over 13. For the next example, we need to express 3 over 8 minus I in the form of a plus bi. So again, we're going to multiply the numerator and the denominator by the conjugate of the denominator. So we multiply the top by 8 plus I and the bottom by 8 plus I. So we get 3 multiplied by 8 plus I over 8 minus I multiplied by 8 plus I. On the top we get 24 plus 3i. On the bottom we get 64 plus 8i minus 8i minus I squared. So again, everywhere we have I squared we change to minus 1. So we're going to get 24 plus 3i on the top. And we have 64 plus 8i minus 8i gives us 0. So we have minus 1 on the bottom. So we have 24 plus 3i on the top, and we have 65 on the bottom. So if we write it with the real part and the imaginary part separately, we're going to have 24 over 65 plus 3i over 65. Okay, in the last problem we have 6 minus 2i over I, again expressing it in the form of a plus bi. So even though on the bottom we don't have the real part, we can still find the conjugate. So we're going to multiply above and below by minus I. So we have 6 minus 2i over I multiplied by minus I on the top and minus I on the bottom. So we're going to have 6 minus 2i multiplied by minus I on the top and I multiplied by minus I on the bottom. So when we multiply out our brackets, we're going to get minus 6i plus 2i squared on the top and minus I squared on the bottom. So when we change our I squared to minus 1, we're going to get minus 6i plus 2 by minus 1 on the top, and we're going to get minus 1 on the bottom. So when we simplify, we're going to get minus 2 minus 6i on the top and 1 on the bottom. So that would just be minus 2 minus 6i. For more information, visit www.PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.